welcome to your Mind IDE. Today we're taking a look at a probability question. This is actually a pretty popular question. I've heard it called the Monty Hall problem. Most likely, if you're watching this, you probably have no idea who Monty Hall is. Or the game show that he used to have. And it's too old for me, so we can also just call it a three-door probability problem. So basically, it's a pretty simple question. And at first, it seems maybe unintuitive, but once you think about it, it's actually pretty straightforward. So the setup of the problem is that one of these doors is going to have a prize. One prize. One is nothing. And one is nothing. So what we're going to do is we're going to assume that the prize is here. So we'll just put a P for prize. So basically the way it works is you pick one door. So we're going to assume that you've picked door 1. Call this 1, 2, 3. So we'll assume that you've picked door 1. Because you don't know where the prize is, each door is going to have a 1/3 chance of being the correct door, which makes sense, right? Like if you're choosing 1 out of 3, you have a 1 in 3 chance of getting it right. So the reason why this is a probability issue is once you pick this door, then they say, okay, well, of the 2 doors that you haven't picked, we're going to open one door. So of course they're going to open door 3, because that one there's no prize in there. And then they say, do you want to stay with door 1 or do you want to switch to door 2? And the problem is which door should you go with, and does it make a difference? So the first intuitive thought is that no matter what, it's going to be a 1 in 3 chance. Whether you stay or you switch, it's going to be a 1 in 3 chance. But that's actually incorrect. So what you want to do is you actually want to switch to door 2. And the reason for that is because this door 1 was a 1 in 3 chance when you picked it. But the way you have to think of it is once you pick this door 1, you've separated these into 2 groups. So you have this group and you have this group. And group 1, which this is group 1, and this is group 2. Group 1 has a 1/3 chance, and group 2 has a 1/3 plus 1/3 equals 2/3 chance. So basically what that means is if you switch, you've actually increased your odds to 2/3. That might not seem to make logical sense, but usually I think the best way to make sense of it is instead of having 3 doors, if you increase the number of doors, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So we have 10, 20, 30, 40, 50. And let's go ahead and shrink this down so that we can get 50 and Oh no. Delete. So we've got 100 doors. Okay. So now, if you think about it, you have a 1 in 100% chance, or a 1% chance of guessing the right door. So when you first pick a door, you pick any door, say you pick this door, you have a 1% chance that the door is correct. Which means door picked is a 1% chance. Now doors not picked is 99 out of 100, or a 99% chance. So that means that the one door that you picked is a 1% chance, and every other door that you haven't picked is a 99% chance. So now let's say they open every single door. All these doors get opened. Every single door here gets opened. All of these doors. Okay. And they say, do you want to stick with the door that you already opened, or that you already picked, or do you want to switch to this other unopened door? So, again, some intuitive perspective might make you think this is a 50-50, but it's not. Because the odds haven't actually changed. So this door that you picked is still 1%, and the doors that you haven't picked, whether these are open or not, are 99%. Which means this one door now has a 99% chance of being the correct door, and this door that you originally guessed has a 1% chance. So you should definitely switch. And I hope that kind of makes sense. Really, if you think about it, the idea is that it doesn't even matter whether these doors have been opened or not. So let's say they're all closed, and they say, okay, you can stick with this door, or you can switch to this door. And if you switch, so the prize is either behind the door that you picked initially, or this other door. Whether they've opened these other doors or not, it doesn't matter. It's still a 99. It's still group 1 and group 2. And group 1 is your first door, 1 out of 100. Group 2 is 99 out of 100. But they're guaranteeing you that if you switch, this will have the prize. If you don't switch, then maybe the prize is behind your door or behind this one other door. So obviously you should switch, because it's going to be a 99 out of 100% chance. So 99% chance. And I hope that makes sense. Basically, yeah, if there's a prize behind one door, if you pick one door, then they open one of the two doors that isn't opened, they don't open the door. So if you pick one door out of the 3, the door that you picked is in one group, the doors that you haven't picked are in a second group, then they open one of the doors in the second group. The second group, the odds don't change, so it retains a 2/3 or 66.6 repeating, or a 33.3 repeating % chance. So you should always switch to the other group, because that will give you better odds. And that is the answer. That's how you do this, solve this problem. So I hope you liked that video, and I hope it was helpful. If it was, please do give the video a like here, and also consider subscribing to the channel. It's a brand new channel, so every subscription really helps me out a lot. Otherwise, thank you so much for watching today, and until next time, take care.